All right, class. So let's go ahead and get started with the Algebra 2 semester exam review for Unit 3. This is actually going to end up being a short video from the others. Topics pretty general. We're going to be discussing a lot of things with quadratics, but primarily systems of equations, and then really just how to plug and chug a lot of the three variable systems of equations. So let's go ahead and get started. But just before we do, just a reminder that your exam is December 8th, Wednesday. You'll have a total of an hour and a half to complete 21 multiple choice questions and 2 free response. We want to make sure that we're as prepped for these as possible. Let's get going. So for this one here, I want you to develop a system of linear equations for the given problem. You don't need to solve it. What I want you to focus on right now is pulling out the information that we have here, and from there understanding what to do with that. So it says a theater sells 3 types of tickets. This is super important. 3 types of tickets. We're going to have general admission, senior citizen, and child. So what I'm going to go ahead and do is I'm going to go ahead and start labeling these as X, Y, and Z. This just like really trains my brain into understanding what we're going to be discussing here. So for general admission, we're going to just set this equal to X. For seniors, okay, we're going to set this to Y, and child will be Z. All right, let's keep going. It says Mark here bought 9 general admission, 2 senior citizen, and 3 child tickets, and paid $170. So a lot of this information is built into that sentence there. So it's really 9x and 2 senior citizens. Well, senior citizens we said was y, so 2y, and 3 child tickets, which is z. And paid, this is usually going to end up being our equal sign when we're talking about money. So if we were going to start pulling this information out, we would say 9x plus 2y plus 3z equals $170. Then they talk about Sarah bought 5 general admission, 4 senior citizens, and 7 child tickets, and paid $173. So really we'd have 5x, 4y, and 7z, and this is going to equal $173. So we'll pull this out. We'll have 5x plus 4y plus 7, oops, let's fix that here, plus 7z, and this will equal $173. And then lastly, because we see that we have 3 variables, well, then we need to have 3 equations, and our last one comes from Kyle, who bought 4 general admission, 1 senior citizen, and 6 child tickets, and paid $116.50. So when we're doing this here, we have 4x, 1y, 6z, and that will equal $116.50. So again, we'll have 4x plus 1y plus 6z, and this equals $116.50. So this is the skill that I want to focus on these first sets of questions, is just being able to pull out the information that's given in the problem. Solving this, luckily for us, we will have a calculator to solve these 3 variable systems. To do this by hand takes me several minutes to do, and again, you have a timed exam, so you won't have to solve these by hand, okay? But let's go ahead and move on. And I want you guys to do the same thing that we just did together on this one on your own. So you're not solving for anything, you just need to read, identify your variables, and then create your 3 variable systems of equations. Again, you have 3 variables, which means that you'll have 3 equations. I will be circulating the class and actually doing all this with you guys in class. So if you have any questions, please let me know. Let's go ahead and move on. So the next thing we want to talk about is when we have systems of equations, well, how many solutions are we going to get? So when we have linear and quadratic systems, there's actually three different types of options that we can have. We can have two solutions, and this happens because we have two intersections. Okay, the lines cross at 2 points. When we have one solution, it only crosses once. And no solution means they don't cross at all. Okay, this is important to know and understand here. So here it says, which graph can be used to find the solution of the following system of equations? So the first equation is y equals x squared plus 2x plus 3. Well, this is a quadratic equation, okay? And then secondly, we have 2y minus 2x equals 10. This is actually going to be linear, and I'm going to prove that here. And if we were going to graph this in the calculator, we want to make sure that we have this in y-intercept form. So to do that, the first thing we want to do is add 2x to both sides, because we just want y isolated on the left side. This simplifies out. I have 2y equals 2x plus 10. And then we're going to divide everything by 2. And this simplifies that, so we're left with y equals x plus 5. This is the other equation that we're going to be graphing. So if you look here, and we were going to graph this, we're looking for solution sets. So it's either answer choice 1, 2, 3, or 4. Well, look at this equation here, y equals x plus 5. We already know that our b, or y-intercept, is at 5, and our m is 1. More importantly, this is a positive number. Okay, so positive slopes meaning that our straight line has to go from left to right. It'll be going up. So we can already cross out number 2, because you'll see here that this guy has a negative slope. Same thing goes for number 4. This is no good. Okay. For 1 and 2, we see positive slopes, and then y-intercepts at 1, 2, 3, 4, 5. This line is good. 1, 2, 3, 4, 5. This line is also good. So what it comes down to is this quadratic. Okay, this y equals x squared plus 2x plus 3. Okay, so how do we do this? Like, there's several ways. You can either graph this in the calculator, and you'll see which graph matches. And if you do have a question like this, and it is a calculator question, definitely graph it. Okay, but also we can look at the points where we have these intersections. Okay, and I know it's a little difficult to see here, but that is another approach to solving this, or simply by graphing points on the equation. My suggestion here also when graphing is you can use test points. Like if I say that x is 0, if I put 0 squared plus 2 times 0 plus 3, well, 0 squared is 0, plus 2 times 0 is 0, plus 3 is 3. So my point would be at 0, 3. Well, at 1, 2, 3, we have a point there. 1, 2, 3, we have a point there. That didn't help. So we can use another test point, and really quickly and easily we can use 1 as a test point. I can say 1 squared plus 2 times 1 plus 3. 1 squared is 1, plus 2 times 1 is 2, plus 3. 1 plus 2 plus 3, that's all going to be 6. So we're going to have a point at 1 comma 6. If I go to 1 comma 6, 1, 2, 3, 4, 5, 6, this works on equation 1. If I look at the third equation, or third graph, I go to 1, and then 1, 2, 3, 4, 5, 6. That doesn't help. Okay, so obviously our answer choice has to be this first one. So there's different ways of looking at this, and I want you guys to be expressed to that. Here we had 2 solutions, 2 equations. Yeah, so this is how we did that one. Let's go ahead and move on to yours. So what I want you guys to do here is you're going to actually be kind of doing the same thing, evaluating the graph. You can graph this by hand. You can graph this in the calculator. You can even try setting these equal to each other and solving, which is another strategy here, and see how many solutions you get. But I want you to identify how many solutions are there for this system of equation. So I'm not asking what they are, I'm asking for how many are there. But let's go ahead and move on. And lastly, like the last thing that we're going to do, the last three problems, is I want you guys to be able to solve three variable systems using the calculator. So I'm expecting this to be a skill that's going to be tested. Don't know for sure. We've done this in Desmos, but I want to make sure that we're able to isolate this and do this in the TI Nspire as well. So for step number one, you want to make sure that you go to menu. And that's what I've done here. When I go to menu, we're then going to go to algebra. Okay, and we see this here. From algebra, your screen is actually going to look a little different than mine. It's not going to give you all of this extra. My calculator does this, yours won't. But the option that you'll have will be this one, to solve system of linear equations. So you're going to have solve systems of linear equations. Okay. From here, it's going to ask, well, how many equations are we going to have? Well, we have 1, 2, 3 equations, right? We see this here. 1, 2, 3. All right, 2 and 3. So we want to make sure that we have 3 equations in x, y, and z. You're going to push OK. And then you're going to have this screen, and you need to make sure that you plug in everything as is. Be very careful with the differences between negatives and minuses. Once you plug that in, you get these values, and these are your answers in order. This is your x, your y, and your z. So your answers would be x equals -1, y equals 1, and z equals 5. This is super, super easy. And luckily you guys have this tool at hand. Again, I actually think this is easier using the TI Nspire than it is on Desmos. Desmos, we have to graph it, kind of work with the sliding bars. It wasn't as straightforward as just putting it into the calculator and doing the system solve. Okay, so I want you guys to practice on that problem, and then I want you all to work on the next two. So you have this one here. It's a 3 variable system. You'll use the calculator to solve this. So you don't have to do this by hand, but you should get this 100% correct. And lastly, on this one as well. So you're going to go through the steps. You're going to go ahead and solve and put in for the system. Yeah. And again, I'll be walking around. If there's an issue with the calculator, or even the day of the test, if you have an issue at the day of the test with the calculator, please make sure that you reach out to me if I'm your proctor, or to any testing proctor, so we can address this issue. Best of luck with this review. Make sure that you finish this up today, as I will be grading this the following day. And we're actually at the halfway point for all of our reviews. So best of luck, guys, and we'll see you all later.